Today we're going to be looking at the law of sines. And before we really get into it, the first thing that we need to point out is that this law is used for any triangle. We don't have to just strictly be dealing with right triangles. This law applies for any triangle, and that's why it is quite useful when it comes to solving triangles. So what this law does is relate the sine of each angle in the triangle to the side across from that angle. And what this law does is it sets up a ratio using the sine of each angle and the side opposite it. So sine of A over A is going to be the same thing as the sine of B over the side opposite it. And the same thing is true for the sine of angle C and the side opposite it. So what this law says is that all of those ratios, sine of A over the side across from it, sine of B over the side across from it, and the sine of the other angle over the side opposite it, those are all going to be equal. So what this law is a bunch of ratios relating those sines with the corresponding sides. They're all equal. So we can write the law like this: sine of A over the side equals sine of B over the side. Or we can actually, since it is just a ratio, we can flip it and write the same exact thing like this, putting the sides on top and the sines on bottom. So, two things to keep in mind. This is going to be true for any triangle. Next thing to keep in mind is that the angle and the side across from it, those stay together. So I mean the letters and whatnot may be different, but just remember that the angle and the side across from it, those stay together. Alright, let's look at a few examples before you start working some of these on your own. So in the first one, let's see, we've got a triangle here, and we are asked to find side BC. And we're giving some limited information here. We know two angles, and we know one side. That's all we know, and we got to find BC. So I'm going to call that side, I'm just going to label it X. So let's see if we can set up the law of sines here. So let's start with what we know. We know angle C is 40 degrees, and we also know the side opposite it. So let's start things off like this. Sine of 40 degrees, I got to keep the 16 with that angle. So sine of 40 degrees over 16. That's how we're going to start this off. And now we're going to see if we can relate the other two pieces of information here to finish setting this up. So the other angle that we know something about is angle A. We know it's 91 degrees. So here we're going to say sine of 91 over, and I have to keep the side opposite it together. So sine of 91 over X. So now what we're going to do is we're just going to see if we can solve this for X. So a couple ways we can look at this. I think maybe the easiest for this setup is just look at it like you're cross multiplying here. So we're going to do sine of 40 times X equals 16 times sine of 91. So sine of 40 degrees times X equals 16 times sine of 91. So again, I'm just trying to figure out what X is here. So X times a number equals something. Finish solving that by dividing by sine of 40. So let's see what x equals here. So 16 times sine of 91 over sine of 40. So notice how I typed it all in at once. 16 sine of 91 over sine of 40. And it looks like it's about 24. We'll just round to 0.9, 24.9. Now, alternatively, we could have set up this problem with the sides on top if we wanted to. So let me show you what that looks like, although I'm not going to bother working it out all the way since we've already got the answer. But just so you're aware, we could also set up this problem just like this. 16 over sine of 40 equals x over sine of 91. And we could have solved that for x and we would arrive at the exact same answer.